What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button, and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
Matters you might think that a wheel disc is not such a complicated part. On the one hand it is, on the other hand not really. Wheel manufacturing requires a certain discipline. You can make mistakes with materials, technology, and even dimensions. And the consequences can be serious, because it's not for nothing that they say that safety starts with the wheels. Even if we ignore the most unpleasant consequence of installing a poor quality disc, its destruction, which is very likely to lead to an accident, all other consequences can also be very upsetting. For example, incorrect outreach will lead to faster destruction of the hub bearing and load other parts of the chassis. Violated geometry can put a cross on the correct balance of the disc and wheel assembly, which will also affect the life of the hub, bearings and tires and some other suspension parts. And it's equally important to use the right metal. An excessively soft disc will require too frequent tightening of nuts on the studs or bolts of the hub, which is not very pleasant. Especially with the irrepressible urge of some of our GAZellists to load 4 tons of different iron into the car, which makes the holes for the studs become oval. And also the disc can crack. It all depends on the hardness of metal and mistakes in its selection in the process of disc manufacturing. In a word, a lot depends on discs, comfort, safety, and resource of other units of the car, some of which will cost much more than a quality disc. Therefore, now we will find out which discs can be considered high quality and which of them can be safely put on the GAZelle. There are many of them and they are different. Let's start by figuring out what kind of discs we will take for the experiment and how we will test them. We will have different discs, both original and third-party manufacturers. But all of them will be tested. What if the analogs turn out to be better than the originals? So, the first set, discs produced by a Togliatti factory. The part number is 1051300182187387, the dimension is 512J x 16H2. They will be paired with discs with part number A21 A23-310101 produced by GAZelle PSHD. These are original GAZ discs. All discs are GAZelle discs. And we will check all these discs on the stand. Discs produced by the Togliatti plant. We use only one stand for testing truck wheels for circumferential bending. The task of testing on the stand is to test all discs according to the requirements of GOSTA 53824-2010 with change 1 from 01 and 07. 2013. In this GOST, its full name is Automobile Vehicles. Non-disassembled wheels. Technical requirements and test methods in paragraph 6.5. 2. A testing of wheels with non-disassembled rim sets out the requirements for testing wheels and bending with rotation. In accordance with them we will test the discs. What will we have to do for this? I will not copy the whole GOST here. It is much more boring to read it than the instructions on an air freshener. If you are interested, you can easily find it on the web. If you're pressed for time, you can read the next paragraph. Everything is described there in accordance with GOSTA 53824-2010. So, 2 discs of alternative production are tested using the maximum wheel load of 1300 kgf. This is the maximum load indicated on the wheel. 2 discs produced by GAZelle PJSC are tested using the maximum wheel load of 825 kgf. This is also the maximum load indicated on the wheel. The test mode is according to GOST, with 2 load stages. The bending moment applied to the discs from Togliatti is 429.52 kgcm at the first stage and 644.28 kgcm at the second stage. The bending moment applied to the discs from GAZelle PJSC on the first stage is 273.405 kgcm, on the second stage, 410.107 kgcm. I will not bore you with calculations of these forces. It will be necessary to give a lot of numbers, which will be too difficult to perceive. I will only say that to calculate the bending moment, we must take into account the maximum static load on the wheel, the static radius of the tire and the rim outreach. As required by the above-mentioned GOST, the minimum required duration of testing one wheel in the first stage is 600,000 cycles. In the second stage, 60,000 cycles. This is what we will do, but first the discs on the stand must be tightened. We have a nut tightening torque of 35 kgcm, and after 10,000 cycles of loading we will tighten the nuts to this value. In general, that's all. What are we to see as a result of the tests? No, we don't. What should we not see? That's more correct. First, we should not see fatigue cracks in the elements of the disc. If they suddenly appear, it means that the disc does not comply with GOST, and it is simply dangerous to put it on the car. And, of course, it will be necessary to control the tightening torque, which should not fall by more than 50% of the original value. This is ideal. Let's see what the harsh life will confront us with. From the ground up. First step. The first disc, it was a product of alternative production, underwent 600,000 cycles of loading and failed the test. According to GOST 53824-2010, discs should remain intact after that, no cracks. But they did appear on the disc, on its flange part. In this case, the test is considered to be failed. It should be noted that the tightening torque of the nuts during the test fell only to 33 to 34 kgsm, that is, within 5.8%, which, with a norm of no more than 50%, GOST 53824-2010 is a good indicator. There are no complaints. If this disc falls apart, its fragments will still remain on the hub. However, this will not make anyone feel better. But there is nothing bad to say about the disc produced by GAZelle. It withstood twice as many loading cycles, 1,200,000, and did not crack. That is, it not only passed the test, but also showed a safety factor of more than 2. Of course, with such iron health it was not difficult for it to maintain the tightening torque, which amounted to 34 to 35 kgcm. There are no questions here, we can pass the second stage of tests. We put new discs, try to break them, and look at the results. To be honest, there's not much to see. The flange part of the disc from Togliatti also cracked after 60,000 cycles of loading, thus destroying the good attitude to discs of this production. And the disc of GAZelle withstood 120,000 cycles of loading without cracks. Maybe it would have withstood even more, but the test was stopped at this number of cycles with the same double factor of reserve. Good for the disc. Both discs showed good tightening torque, the same 33 to 34 kgcm for the analog and 34 to 35 for GAZelle. I think there is no need to make some long conclusion. If the gas discs easily passed the tests and showed double safety margin, the discs of non-original production failed these tests. And literally with a bang, with the flange part cracking. It is a shame that the tests were not some extreme, but for simple compliance with GOST, there should not be any errors at all. However, it turned out that putting discs from Togliatti is not only harmful for the car, but also simply dangerous. Especially if you plan to use the car on bad roads, which we have much more than good roads, and with overloading, and many people cannot drive without them because of religion. Probably, it is worth to feel sorry for yourself and the car, and do not spare money for the original gas discs. And another couple, we have 2 more discs from an alternative manufacturer from Yaroslavl. We would like to evaluate them somehow, but we need too many discs for the bench, 2 copies of each sample, and we don't have so many. So we will just give them to the laboratory for geometry evaluation. Without a bench we can't get objective data about disc strength. The first wheel has the part code 050009-107-3704 and it is an analog of the gas disc 102-3101015-20. The second third-party disc is 0500-099-7780 and it is an analog of GAZ 102-310101015-01. Discs from the manufacturer from Yaroslavl. The laboratory measured the following parameters: appearance of welds, depth of pressing, distance from the edge of the spoke to the weld, length of the weld, parallelism of the rim flanges, radial and end runout. Since there are a lot of figures, I will limit myself to quotations from the report's conclusions. The first wheel, the distance from the spoke edge and the length of the wheel weld were not maintained. This discrepancy reduces the strength and life of the wheel. Second, the length of the wheel weld is not maintained. This discrepancy reduces the strength and life of the wheel. Welding wire residue is unsatisfactory appearance of the wheel, injury hazard. Radial runout and pressing depth are not maintained, leads to vehicle vibration. There is probably no need to comment here. Both discs will not serve as long as original gas discs can, and with the second disc the car will also shake. This disc also hits. For those who like numbers, the norm for radial runout is not more than 0.7 mm. In the sample it was 0.9 mm. And runout is within the norm. Will it get there or not? Well, how not to remember our dear Nikolai Vasilyevich Gogol with his immortal, "See," said one of them to the other, "there's a wheel. What do you think, would that wheel, if it happened to go to Moscow, or would it not?" "It would," replied the other. "And to Kazan, do you think it would not go?" "It will not go to Kazan," replied the other. That was the end of the conversation. Following the Gogol's men we end the conversation, they said everything right. The non-original discs, which took part in the tests and were measured in the laboratory, may reach Moscow, but they won't reach Kazan. Though about Moscow it's not for sure either. It is definitely not worth saving on discs, it will cost more, even if they suddenly make it to the destination. In conclusion, our examination of GAZelle rims on the wheel test bench has revealed some intriguing insights into their performance and durability. While these rims are designed to withstand significant stress, the testing process has shown that they can exhibit cracking under certain conditions. Understanding these behaviors is crucial for both manufacturers and consumers, as it highlights the importance of quality assurance in automotive components. As we continue to push the boundaries of performance, ongoing testing and innovation will be key to ensuring safety and reliability on the road. Thank you for watching, and stay tuned for more in-depth analyses on automotive technology.